Okay, we're going to practice doing some double replacement reactions. You should have your ion sheet out while we do these because that will help you figure out the charges for the ions. Also your periodic table. Back of your periodic table is helpful too for these polyatomic ions. So essentially what we have here are two compounds. And when we have two compounds reacting, it's going to be a double replacement reaction. Remember, the calcium and the hydrogen will swap places, and basically they're going to swap partners to form two new compounds. That's what a double replacement reaction is. My suggestion is to start out by assigning each one a charge. So we're going to kind of work backwards like we did in the last chapter, and we're going to figure out what ions are these made up of. So calcium is in group 2 on the periodic table, has a +2 charge. Hydroxide has a -1 charge. Hydrogen has a +1 charge, and the polyatomic ion phosphate has a -3 charge. That's what I think you should do every time you try to do these polyatomic, or I'm sorry, it's polyatomic ions, every time you try to predict the products of a double replacement reaction. So at this point, it makes it really easy. You're going to bring calcium together with phosphate, and those are going to form a chemical bond because remember, the calcium is going to swap places with the hydrogen. So the positive ion from this compound is going to hook up with the negative ion from this compound. And they need to do so in the correct ratio. Like we learned in chapter 7 and 8, if you put a positive ion together with a negative ion, the sum of the charges has to equal 0. So we need to figure out what ratio would calcium and phosphate come together in. Well, they would come together in a 3:2 ratio. So the formula would be Ca3 and then PO4. We would need 2 of those. Then we need to look at hydrogen and hydroxide. Those two are going to come together. When hydrogen and hydroxide come together, it forms HOH, +1, -1, but we rewrite that as H2O because if we have an HOH that's forming, it's called water. So those are the correct formulas for the products. Once we have the correct formulas for the products, we need to go back and balance the equation. That's the next step. So I'm going to go back and I'm going to balance the chemical equation. It's the way I taught you to. We have 3 calcium on the product side, so I'm going to put a 3 in front of here, which also gives us 6 hydroxides. Hydroxide did not stay together though, so we're going to have to balance these hydrogens and oxygens separately. I'm going to look at phosphate. I have 2 phosphate on the product side, so I'm going to put a 2 here so that I have 2 phosphate on the reactant side. Now I'm going to take account of the hydrogens. 3 times 2 hydrogens, I have 6 hydrogens in this compound, and then I have 2 times 3, another 6 hydrogens in this compound, for a total of 12 hydrogen on the reactant side. So if I want to have 12 hydrogen on the product side, I'm going to put a 6 here. And now I need to keep track of my oxygens. I have 6 remaining oxygen on the product side that weren't part of the phosphate, and I have 2 times 3, 6 oxygens on the reactant side. So now my equation is balanced. At this point, it's not necessary to put a 1 in front of this or in front of the calcium phosphate unless you want to. All right, let's go on to the next one. Again, we start out the same way. I'm going to give potassium +1 charge, carbonate -2 charge, barium +2 charge, and chlorine has a -1 charge. Those are the ions that make up those ionic compounds. My positive potassium is going to come together with chlorine in a 1:1 ratio because they are +1, -1. And then I have a barium with a 2+ and a carbonate with a 2-. Those are going to come together in a 1:1 ratio as well, BaCO3. Then I need to go back and I'm going to balance my equation now. So I have 2 potassium in the reactants, so I need to put a 2 here, which also gives me 2 chlorines, which is good because I have 2 chlorines here. I have 1 barium, 1 carbonate, 1 barium, 1 carbonate. This is a balanced equation at this point. All right, I will do one more example. Okay, now this one's a little bit trickier because we have cadmium. Cadmium is one of those transition metals that is going to need a Roman numeral. So we're going to have to figure out which cadmium this is, because there's no set rule for determining the charge on a transition metal because they can have multiple oxidation states. So I need to look to phosphate. Phosphate has a -3 charge, and there are two of them. So I have a total of -6 charge. I have 3 cadmium in this chemical formula. Those 3 cadmium need to add up to a total of a +6 charge so that the sum of my charges is 0. That means that each cadmium had a +2 charge. Now, why is this important? Because we're going to be putting cadmium together with sulfur over here. So let's do these. NH4, that's our ammonium ion with a +1 charge. Sulfur has a -2 charge. So when I bring my +2 cadmium together with my -2 sulfur, it's going to be CdS. +1 or +2, -2, sum of the charges is 0. Now, phosphate, as I mentioned earlier, phosphate has a -3 charge. Sorry about that. That's a 3. -3 charge. Oh my goodness. All right, let me try that again. Phosphate, PO4, has a -3 charge. So if I bring ammonium together with phosphate, which is what's going to happen, I'm going to need 3 +1 ammoniums to come together with 1 -3 phosphate. So now that I have correctly determined the chemical formulas for the products, I need to go back and balance the equation. I have 3 cadmium on the reactant side, so I'm going to put a 3 here, which changes the number of sulfurs I have as well. So I'm going to go ahead and put a 3 in front of here so that I have 3 sulfurs. That gives me 6 ammonia on the reactant side. So I need to put a 2 here so that I have 6 ammonia on the product side. And that also gives me 2 phosphates, and I have 2 phosphates on the reactant side. So now my equation is balanced. All my formulas have been written correctly. So that is how you do double replacement. Always go through, figure out the positive and negative ions in each formula. The positive ion from the first formula will go with the negative ion from the second formula for double replacement reactions.